This lesson is on graphing exponential functions. Okay, taking a picture here of a bar graph. And the bar graph is mall browsing time and average amount spent. We know that anybody who works in a mall or who owns a business in a mall wants you to be in the mall for as long as you can, because the longer you're there, the more you spend. But it's not a linear function, it's an exponential function. So what we have here is a function, and this function is 42.2 times the constant 1.56 raised to the x power, where x is the time in hours that you spend at the mall, and f of x is the amount of dollars that you spend. Now you could connect the midpoints of each one of these bar graphs, and then you could see that it is a function that goes in a curve. But right now we're just using the bar graph. All right. So the exponential function with base b is f of x equals b raised to the x power. You can also call this y equals b raised to the x power, and we'll be using this when we get to logarithms. B is a positive constant other than 1. And the reason for that is if b was 1, no matter what we raise it to, we would still get 1. So we can't allow b to be 1 because there would be no growth or no decay. And b must be greater than 0 and not equal to 1. X, the exponent, is any real number. And that can be a half is a real number, pi is a real number, it's irrational but it's still real. Square root of 2 is a real number. 6 is a real number. Okay, let's talk about exponential functions. F of x equals 2 raised to the x power. 2 is the constant, x is the exponent. And that has a base of 2. G of x is 10 raised to the x power. And that means that the base here is 10. Or we could have h of x is 1/2 raised to the x plus 1 power. And that is, the base is 1/2. And finally, we say the constant base, we have a constant base, my mouth's not working today, and a variable exponent. Okay, these are some examples of non-exponential functions. F of x equals x squared. And the reason for that is there's a variable in the base, and that can't be. Or g of x is 1 raised to the x power. Once again, that would never change. That would always remain 1 no matter what your value for x is. And h of x is negative 1 to the x power. Well, you know the base has to be greater than 0, so that's not going to work. Or j of x is x to the x power, and that doesn't work because the base cannot be a variable. So there are some examples of what are and what are not exponential functions. All right, let's take a look at an example. Let's go back to the mall example. And this was the exponential function that modeled how much money you would spend at the mall based on how many hours you were there. Okay, what is the average amount spent, which would be f of x, after 4 hours? Well, we're going to substitute x for 4. So we'll have f of 4 equals 42.2 times 1.56 raised to the 4th power. And on your calculator, and please practice this to make sure that you're getting the right answers. On a scientific calculator, you would plug in 42.2, then your multiplication function, and then 1.56, and y raised to the x power, and then 4. And that's going to take 1.56 and raise it to the 4th power, and then your equal sign. On a graphing calculator, it's a little bit different. It's going to be 42.2 times 1.56, and then you have your little up arrow and a 4 and enter. And you should get, we're going to round to the nearest whole number, $250. So at 4 hours, it's going to be about $250 is how much you would spend. All right, go ahead and do your checkpoint number 1. And by the way, your checkpoint number 1, you have to refer back to that bar graph. Okay, example 2. Graph this function. F of x is 2 raised to the x power. Well, we're going to make a little chart here, and we're going to choose our x's as minus 3, minus 2, minus 1, 0, 1, 2, 3. So when I raise 2 to the negative 3 power, remember that when you have a negative in an exponent, it doesn't mean the number is negative, it means find the reciprocal. So this would be the same as 1 over 2 cubed, which is 1 over 8. So when x is negative 2, you'll have 1/4. When x is negative 1, you'll have 1/2. And x is 0, you have 1. 1 is 2, 2 is 4, 3 is 8. So if we want to graph this, there's our negative 3, 1/8, and so on. Negative 2, 1/4, negative 1, 1/2, 0, 1, 1, 2, 2, 4, 3, 8. And if we connect all of these, that's what our graph looks like. I'm not real good at drawing it, but that's about what it should look like. Okay, the domain of this graph is real numbers, all real numbers. X can be anything. The range is going to be, you notice that the graph never goes below the x-axis, and it actually doesn't even touch the x-axis, so it's going to be, the range is going to be 0 not included up through positive infinity. There's a horizontal asymptote. An asymptote is a line that the graph approaches but never reaches, and that horizontal asymptote is y equals 0 or the x-axis. All right, go ahead and do your checkpoint number 2 and come back. Example 3. Graph g of x is 1/2 raised to the x power. And once again, we're going to start with our x and 1/2 raised to the x power and our values for x. And what we're going to notice is our values for y are going to go in the opposite order. So we'll have 8, 4, 2, 1, 1/2, 1/4, 1/8. So it's coming down instead of going up this time. So if we graph these, they look like this. So we can connect that. And notice once again, we have the same thing, it just instead of going from small to large, it's going from large to small. It's decreasing, so it's a decreasing function. It goes down and to the right. The domain is, once again, all real numbers, and the range, again, is from 0 not included to positive infinity. The horizontal asymptote, once again, is y equals 0, which is the x-axis. Okay, so go ahead and do your checkpoint number 3. Notice, f of x equals 2 raised to the x and g of x equals 1/2 raised to the x are reflections of each other over the y-axis. Now we've done this before with even and odd functions, and remember the cosine was an even function because it reflects over the y-axis. So in our case here, our first one went like this and our second one went like this, and you can see that they are just mirror images of each other. And they share one point in common, and that is 0, 1. Even. And what that means is f of negative x equals f of x. 1/2 raised to the x power is the same thing as 2 to the negative 1 raised to the x power, which is 2 to the negative x, which is the same as f of negative x. Okay, characteristics of exponential functions. You need to have these memorized. All right. First of all, the domain is all real numbers for y is greater than 0. This is for the parent function, f of x equals b raised to the x power. All go through the point 0, 1. Because f of 0 would be b raised to the 0 power, which is 1. B cannot be equal to 0. If b is greater than 1, f of x equals b raised to the x, the graph goes up to the right. Starts low, goes high, which means it's an increasing function. The greater the value of b, the steeper the graph. Okay? If b lies between 0 and 1, the graph goes down to the right and is a decreasing function. The smaller the value of b, the steeper the decrease. F of x equals b raised to the x is a one-to-one function and has an inverse that's also a function. And the graph of f of x equals b raised to the x approaches the x-axis, which is y equals 0, and which is a horizontal asymptote. That's a lot to take in, but you're going to get to put this to use here shortly. Okay, friends, we will see you in class. Have a good day.